So this is the fifth topic of block 1, General Physics, which is about the forces. In this topic, we discuss about the effects of the forces, what the force can do, and different formulas which we will use to calculate the force. So the subtopic is the effects of the forces. These are the learning objectives. You should be able to recognize that force can change the shape, size, or the speed of an object. We should be able to plot or interpret force extension graph or load extension graph. And when there's a resultant or two or more forces acting on the same line, so there is a resultant force and the formulas which are related to calculating or calculation of the force, and understand the friction between the two surfaces and recognize the air resistance as a form of friction. So we'll discuss this part. First, we start with the definition of the force. How you define a force? So basically a push or a pull. A simple definition of the force. Force can be a push or pull. That is when we when we exert a force, either it will be a push or a pull. Like example, if a box is there which is resting on the ground, so if you are applying force on the object, we call that as a push. But if you apply force away from the object, then we call that as a pull. So this will be pull and here it is push. So force is basically a push or a pull. And what force can do, the force can change the size. Like example, if you have a can, an empty can, you apply the force on the can, so you are reducing its size. Or example, a sponge, you apply force on the sponge, you compress the sponge, so what you will find, the size will decrease. So using a force, we can reduce the size, we can change the shape, or we can change the direction of the motion, or we can change the motion of an object. What is the meaning of motion of an object? Like example, if there is a box which is lying on the floor or it is at rest, so by applying a force, what I can do, I can change its motion, I can change its state. Like if something is at rest, by applying a force, push or a pull, I can move it. Or if something is moving, like example, an object, a rolling object is there, or a rolling sphere on the surface, and it is moving towards you. So by applying a force, this is the direction of the motion of this rolling sphere. So by applying a force in opposite direction, what you can do, you can stop this moving object. So these are the effect of the forces or force. A force can change the size of an object, like example sponge. A force can change the shape of an object, like example a can, empty can. When you apply a force, you can change the shape. And force can change the direction of, or force can change the motion. Like if object is stationary, it can make the object move, or if object is moving, it can change the state of an object, it can stop the object, or even it can change the speed of an object as well. And what is the SI unit of the force? The SI unit of the force is Newton. And how we can measure a force can be measured by a spring balance. So if you remember, when we did the topic mass and weight, we mentioned that weight can be calculated by a spring balance, and here we are saying force can be also calculated by a, or measured by a spring balance. So why force can also be measured by a spring balance? Because weight is also a kind of force. So using a spring balance, I will attach an object here. I can know how many Newton this object is, or what is the weight of this object. But normally, like the common spring balances which are available, you don't find it is written Newton. On those spring balance, either they write kilogram or gram. They do not write Newton. Why they are not? Actually, it is measuring a force in Newton, but the scale calibration, they for your convenience, because you're more familiar to mass in gram and kilogram rather than the weight of an object. That's why they're giving you or showing you the number in kilogram or gram. But in reality, the spring balance is actually measuring a weight, and that weight is converted into mass, which the number showing on the balance. Is it clear? The concept of the force? Anyone having a doubt or a question till now? And there are different examples of the force. Friction is a force, weight is a force, air resistance when you are moving, electrostatic, that we'll discuss in block 4, and magnetic forces, that is between the magnets. As like example, very common, you will feel or experience this example. If you place two magnets, if their like poles are facing each other or identical poles are facing each other, so what they will do, they will attract or repel. Will they move towards each other or away from each other? If the like poles or identical poles are facing each other, so this is the north pole, south, north, south. So like poles or identical poles of the magnet, they will move away from each other or they will repel. So, and the force between the magnet, what we call that force, we call that as a magnetic force. And what is the electrostatic force? The force between the charges. Like example, if there is a positive charge and a negative charge, it's not necessary they have the same size, they may have different size. If positive and negative charges, unlike charges, they attract each other. So as they attract each other, the force between them is called electrostatic force. So force between the ions, between the charges, or electrons, protons, they all have charges, so we call that as an electrostatic force. And force between the magnet is known as magnetic force. The force of the air which oppose your motion, we call that as a air resistance. The force by which the gravity is attracting you towards its center, towards the center of the planet, we call that as weight. And the force which resists your motion, like example, there's a friction between, like when you're in contact or when your feet are in contact with, when your feet are in contact with the ground, so there's a friction between the shoe and the ground, and that is known as a, or there's a force between the shoe and the ground, that is known as a frictional force. So these are some examples of the forces. Is it clear, this part? Then the next part will discuss the effects of the forces, like how a force can change the shape, how a force can change the size, or how a force can change the motion or speed of an object. Example, the first one, effect of force on the size of an object, or we also call deformation. Like example, what is the concept of a deformation? Example, if you have a spring which is fixed from one end and you pull it from the other side, what will happen to the size of a spring? It will increase or decrease? What will, it is fixed from the top and you are pulling it from the bottom, what will happen to the size of the spring? So the size of the spring will increase. So when the object changes its size or shape, we call that it is deformation. And what is the meaning of elastic deformation? The term elastic, if I release, if I remove this force, when I remove my force and I'm not applying any force on this spring, what will happen? This spring will return back to the same original position, same original size. So when the spring will return to the same original size, we call that as a elastic deformation. Like there's a deformation, there's a change in shape and size, but the term elastic means when the force is removed or the force is released, the object will return back to the same original position. If object does not return back to the same original position, then we call that as a plastic deformation. So there are two types of deformation. One is elastic, another one is plastic. So if I have an object, like example, say sponge, and the size, the height, or one dimension only I'm considering. So this dimension, this side is 2 centimeter long. I apply the force on the sponge, I compress, and the sponge size reduces, the length reduces to 1 centimeter. When I release the forces, when I remove the forces, it returned back to the same 2 centimeter. What kind of deformation is this? Elastic or plastic? If it returned back to the same 2 centimeter length, what kind of deformation is this? So it is elastic deformation because it returned back to the same original length, shape or size. But what will happen, because sometime a deformation might occur, so instead of returning back to same 2 centimeter length, maybe it might return to 1.8 centimeter. So if it deformed completely, original length is not same as the final length when the force is removed, so we call that spring is plastically deformed. So a deformation can be elastic or it can be a plastic. Then what is the definition of elasticity or elastic material? So if the when we apply the force on the object, we stretch or compress the object. If the object can return back to the same original length when the force is removed, we call those objects as elastic body, and this property is known as elasticity. So like example, if you take a rubber band, and the size of this rubber band is, let's say, 2.5 centimeter. You stretch, you apply the force, and you deform this, you remove the force, it is permanently deformed, and now the new length is 3.8 centimeter. What is this type of deformation, elastic or plastic? You stretch the rubber band and then you release the force, it is now 3.8 centimeter. So it is a plastic deformation as it does not return. But what will happen when you remove the force and if it return to the same original length, we call that rubber band as elastic body, and we say that deformation is elastic deformation, and the property is known as elasticity. So elasticity means capability of the material to return back to the same original length. So if the material can return back to the same original length, we call it is an elastic material. If it does not, then we call that as a plastic material or plastic deformation. So example, you have unstretched spring. Unstretched spring means you did not apply any force on the spring, and the unstretched spring having a length of 40 millimeter. Then you stretch the spring now by a force of 1 Newton, now it is 50 millimeter. Then you attach a 2 Newton load, now it is a length of 60 millimeter. So how much the increase in length is there, the difference between the stretch and the unstretched length is known as extension. So example, originally spring was 40 millimeter long, which is not stretched. Okay, that is the original length. When you apply a force of 1 Newton, the new length of the spring is 50 millimeter when 1 Newton is attached. Can you identify what is the extension? What is the increase in the size from the original? What is the extension of this spring? Originally it was 40 millimeter. Now by attaching a 1 Newton load, it is 50 millimeter. So how much the size increases? The size increases by 10 millimeter. So we'll say extension is 10 millimeter. If we attach another load, like example, we attach 2 Newton, and now the total length is 60 millimeter. So what is the extension? Extension is always calculated from the original. So originally it was 40, but now it is 60. So always the original length, the formula of extension is original length is there, and the stretch length. So stretch length minus the original length will get the extension. So 60 minus original 40. So we'll get extension as 20 millimeter. So there is a law which explains the idea that it state, that's known as the Hooke's law. What it is state? It is state that a material which obey a Hooke's law, the extension is directly proportional to the stretching force. What does it mean? The extension is directly proportional to stretching force. Like you can see in the previous example, when I apply a force of 1 Newton. So when we apply a force of 1 Newton, what was the extension? Extension was 10. But when we apply a force of 2 newtons, what is the extension now, or what is the increase in size? That is 20. So Hooke's law state that when you increase the force, or when you apply a greater force on the object, it will have a greater extension. So if I have a spring, which is unstretched, and originally it is having a length of 5 centimeter, that is the length of unstretched spring. Now what happened? If we apply a load, if we attach a load of 5 Newton or 10 Newton example, and a load of 20 Newton, which one will produce a greater extension? Which load or which force will produce a greater change in the length for a spring? A load of 10 Newton or a load of 20 Newton? Which force or a load will increase the size of the spring? A 10 Newton or a 20 Newton? You have a spring which is having a size of 5 centimeter. Okay, that is the length of the spring, the original length or length of unstretched spring. So length of the unstretched spring is equals to 5 centimeter. You have two loads available, you have two masses available. One is having a 10 Newton, another one is 20 Newton. My question is that which load will produce a greater extension, greater increase in size of the spring? Load of 10 Newton, which is A, load of 20 Newton, which is B. So which load will produce a greater extension? So a load of 20 Newton will produce a greater extension as compared to load of 10 Newton, so B. So that is a simple Hooke's law. Hooke's law states that if we apply a greater load or a greater weight or a greater force, the spring will have a greater extension. So load and extension are directly proportional. The term directly proportional means if we increase one quantity, in mathematics you will study in detail about the directly proportional relation. But in short, the direct proportional relation means if we increase one quantity, the other will also increase. And if we decrease one quantity, the other will also decrease. So according to Hooke's law, force and extension are directly proportional. If you increase the force, the extension will also increase. Greater the force, greater the extension or increase in the size of the spring. But there is a limit for using the Hooke's law. According to Hooke's law, within limit of proportionality, what does it mean? Like objects should not deform. Example, you have a spring. The definition of Hooke's law state force and extension are directly proportional. This is a term which is used when one quantity is increasing, the other is also increasing. So a material obey a Hooke's law, if the extension is directly proportional to the stretching force. Within limit of proportionality. What does it mean within limit of proportionality? Like example, if I have a spring which is having a length of 5 centimeter, the unstretched spring. Now what we did, we attach a load of 10 Newton. So when we attach a load of 10 Newton, now the length of the spring example is 7 centimeter. What is the extension here? When I attach a load of 10 Newton, the new length is 7 centimeter. What is the extension here in this example? Extension means increase in length. So it is extended by 2 centimeters. So extension is 2 centimeter. If I attach a load of 20 Newton, I double the load. Sorry, 20 Newton. First it was 10, now it's 20. And the length is now 11 centimeter. So what is the extension? When I attach a load of 20 Newton, the extension, originally it is 5, or example it is 9 centimeter now. Instead of 11, example 9 centimeter. First it was 5, then I attach a load of 10 Newton, it is 7, so extension is 2. Then I attach a load of 20 Newton, now it is 9 centimeters, so what is the extension? Extension is 4. So you can see here about the force and extension. When no force was there, no extension. You can see in this example, the beginning, when there is no force on the spring, there was no extension. So when force is 0, extension is 0. But when the force is 10, extension was 2. When a force is 20, so if the force is double, what will happen to extension? The extension will also double. So 2 multiplied by 2, so extension will be 4. So that is the meaning of the proportionality, that if one quantity is double, the other quantity will be double. If one quantity is 3 times, the other quantity will also be 3 times. So if I say what will be the extension, what will be the extension if I attach a 30 Newton load? How much is the extension if I attach a 30 Newton load? Yeah, what will be the extension, increase in the length, if we attach a 30 Newton load? Extension. So how you can work out? You can simply work out when it was 10, the extension was 2. I'm talking about extension, Abdullah. Extension means increase in the length. So if force is 10, the extension was 2. But now the force is 30. So what it means? The force become 3 times. So if the force become 3 times, what will be the extension? The extension will also become 3 times. So what will be the extension? It will be 6 centimeter. 6 centimeter will be the extension. And what is the total length? The total length is original length plus extension. So originally it is 5 and extension is 6. So the total length will be 11 centimeter. Is it clear the concept of the Hooke's law? That what it is state, Hooke's law simply state that force and extension are directly proportional. That when you increase the force, the same factor extension will also increase. Yes, you can do from 20 to 30. That can also be done. If you select from 20 to 30, like example, I select 10 change to 30. But if you select 20 change to 30, then what happened? Look, if 20 is changing into 30, it means 20 multiplied by which number to get 30? So 20 multiplied by 1.5, 20 into 1.5, you'll get 30. So it means 4 multiplied by 1.5. So 4 multiplied by 1.5, you will get 6. So you will get the same answer. It won't make a difference. You can take any value, just identify what factor it is multiplied, and you will get the extension. So in short, what is the meaning of Hooke's law? It states that force and extension are directly proportional. If force is multiplied by any number, the extension will also multiply it with the same number. But there is a condition that within limit of proportionality. What is the meaning of within limit of proportionality? It means that the spring should not deform plastically. Like example, the original length of the spring is 5 centimeter. Okay, I attach a load of 100 Newton, and this length of a spring example is 15 centimeter. What is the extension? Extension is the stretch length minus the original length. So what is the extension or increase in the length? The extension is 10 centimeter. If I remove the load, if I remove this load, what should be the length of the spring? If I remove the load, what should be the length of the spring? It should be 5 centimeter, but sometime what happen when we attach very or too large object or heavy objects, then the spring might not return back to the same original length. Maybe the spring is now 5.5 centimeter. So what does it mean? This means that this spring, it means, yeah, it can be 6 or 7 or any number. It means this spring is having which kind of deformation, elastic or plastic? So it is not elastic, it is a plastic deformation. So when the spring is having a plastic deformation, it will not obey the Hooke's law. So within limit of proportionality, within the elastic limit, the spring will obey the Hooke's law. But once it is crossing the elastic limit, once it crosses or plastically it will deform, it will not obey the Hooke's law. And what does it mean? Like if I say values for a spring which is not obeying a Hooke's law, like here it is 0 and 0. I apply a force of 100, the extension was 10 centimeter. If I apply a force of 200, so if I double the force and spring is plastically deformed, Hooke's law does not only mean stretching the spring, it means when you apply the force, the spring will stretch, but force, the factor by which force is multiplied by the same factor, extension is multiplied. Like example, I was applying a force of 100 Newton and extension was 10. Then I apply a force of 200 Newton. So how much should be the extension? It should be double. So if double means what should be the extension here? What should be the extension? If force is double, extension should be double. So it should be 20. But sometime what happens, spring is not obeying the Hooke's law. It becomes 22. So it is not multiplied by 2. So if it is not multiplied by 2 or not multiplied by a same factor, it means this spring does not obey the Hooke's law. Hooke's law states force and extension are directly proportional. When you increase the force, the extension will also increase with the same factor within limit of proportionality. If the spring crosses the limit of proportionality, it will not obey the Hooke's law. Is it clear? So using the table, yes, Abdullah?
Sir, why did it become 22? We are applying the same Newton force.
Yeah, we are increasing the same Newton force, but it should be 20, but it is 22. So what could be a reason? The reason is that the spring might have a plastic deformation. So when object is having a plastic deformation, it become easy to stretch. That's why it extended more than what we suggested. Clear?
Yes, sir.
So another example, using the data, using the number, you can also identify that spring is obeying a Hooke's law or no. Example, forces 2, 4, 6, 8, 10. Extension was 5, 10, 15, 20, 25. Okay. Using the data, can you identify whether this spring is obeying a Hooke's law? Yes or no? And it's not like check only one value, you have to check all the values. Does this spring obey Hooke's law? So this spring is obeying a Hooke's law, and how we identify, you can check the number. 0, you don't have to check 0, as this is multiplied by 2, this is also multiplied by 2. You can take any two number. It's just 2 and here is 8. So 2 become 8, it means it is multiplied by 4. And 5 become 20, that is also multiplied by 4. So this spring is obeying a Hooke's law. But sometime spring obey Hooke's law for only 2 3 values and then it deformed plastically. So if it is not, if it initially it is obeying a Hooke's law and then it does not, so we say it is not obeying a Hooke's law. 0 and 0, say this was 50 Newton, it cost 2 centimeter. 100 Newton cost 4 centimeter. Then 150 Newton will cause 7 centimeter extension. So when we check, 50 become 100. So if force is multiplied by 2, extension multiplied by 2. Force is multiplied by 3, extension should be multiplied by 3. So 2 multiplied by 3 is 6, but here we are getting 7. So it means this is the data for a spring which is not obeying a Hooke's law. And this was a data for a spring obeying a Hooke's law. Is it clear? So this spring was obeying a Hooke's law till 100 Newton force, and after that it does not obey the Hooke's law. And this spring is obeying the Hooke's law for all the forces which are applied. Is it clear? The data, how to distinguish the spring obeys the Hooke's law from a data. If the force and extension increase with the same rate, it means it is obeying a Hooke's law. So when we plot a graph for force and extension, the table example shows the extension of a spring of S spring varies with the force applied. Like we apply a force of 1 Newton, extension was 10. Is this spring obeying a Hooke's law till what point? Can you identify till what force it is obeying the Hooke's law? So when you check till this point, when load is 4, extension is 40, till this 1 to 4 it is obeying a Hooke's law, but after that it does not obey the Hooke's law. So when we plot this graph from the reading, we plot a graph, or so how it will appear? It will appear like this: load and extension. So the last point where the spring is obeying a Hooke's law, the last point where the spring is obeying a Hooke's law, this is the region where the spring obey a Hooke's law, and after that it will become curve. So straight part, when force and extension graph, the straight line is there, it means that region spring is obeying a Hooke's law, and after that it is not obeying the Hooke's law. And then it will have a deformation, it can have a plastic deformation. And the last point where the spring is obeying a Hooke's law, that last point is known as limit of proportionality. The last point where the spring is obeying a Hooke's law. So this will be the graph, how it will appear for a force and extension. Any question related to Hooke's law? Is it clear? I will just quickly repeat. What is the definition or statement of a Hooke's law? Laws having a statement. The laws having a statement, it says that force and extension are directly proportional to each other. If you increase the force, it does not mean only increase, it means directly proportional, which means that they increase with the same factor. So I'll share another link and continue this discussion of Hooke's law.